Okay, let's do more separation of variables. I want you to actually see if you can do number 1. Stop the video, don't look at anything, and see if you can work number 1 all the way through. And hopefully when you come back, you will know the steps of separating. I'll go ahead and write that to the 1/2. And dx. After I do that, I will integrate. So I'm going to integrate, and I'm going to integrate. I get y equals. So I have -3/4. I increase the power by 1. So that would be 3/2. I multiply by 2/3. I can't forget my plus c. So let me clean that up just a smidge. That's negative, let's see, those cancel, -1/2 x to the 3/2 plus c. When I put in 0 for x, I should get out 10. So in fact, I get c being 10. And remember my answer, I go right back up here where I plugged in the initial condition. So I'd get y equals -1/2 x to the 3/2 plus 10. So notice, like I said, in the ones that we've done, I've always plugged in my initial condition right there, right after I integrate. And I said, well, there's one exception to that, and that's what we're going to look at today. So let's look at this one. It says at each point x, y on the certain curve, the slope of the curve is 3/4 y. Now, they just said that in words. I certainly hope that if you were given that, you'd say, oh, if the slope of the curve is, they really said dy dx is 3/4 y. That's what this whole sentence is saying. If the curve contains the point 0, 10, find its equation. So again, solve the differential equation. So let's look at this one. The steps are, first step is the same. I'm going to separate the variables. So I have dy over y, and I'll leave the 3/4 with the dx. And after that, what do? I integrate, of course. So I'm going to integrate and integrate. Now, what do I get when I integrate? On the left, I get the natural log, that's u prime over u, so that's the natural log of the absolute value of y is equal to 3/4 x plus c. Now, I'm telling you, it is my opinion, when you end up getting a natural log on that side, the natural log of y or y plus 1 or whatever, I do not solve for c in that step. I go ahead and solve for y first, and then I solve for c because I think it becomes a lot easier. Now, these steps you'd be like, oh gosh, I never would have thought of that. Well, you will after you've seen it. So here's the deal. How do you undo an ln? Remember, you have power when you have an equation as long as you do it to both sides. So I'm going to e to the both sides. So I'm going to e to the this. Let me go ahead and write it on another line so you see the integration. So I'm just recopying here. But I'm going to do e to the that power and e to the that power. So when I do that, I still have the absolute value of y. And what I have on the left is e to the this thing. And you go, well, that doesn't look any nicer. Yeah, but let me use some exponential properties. Do you remember the property that says if I have like x to the 3rd times x to the 5th, you would tell me that that's x to the 8th, right? So you would do 3 plus 5. Well, because most of the times you're going this way. Well, in this case, I'm going back like this. I have e to the, so I have a base, and I have two things that are added, two exponents that are added. So I'm going to write that as e to the 3/4 x times e to the c. Now here's the part where you can drop the absolute value, and here's why. Because the absolute value means plus or minus, right? You could have a positive or negative. Well, this right here, what kind of thing is e to the c? E to some constant is in fact another constant. So this c and this c are different, but nevertheless, they're constants. So I can replace this whole thing with, I call it big C, and that C could be plus or minus, so that's where I can drop the absolute value, and then I would have this left. You can see in this place, it's so much easier. If you're solving for C, you put in your 0, 10, your initial condition. E to the 0 is 1. I get C equals 10. So I go right back here where I plugged in my initial condition, and I get Y equals 10e to the 3/4 x. That's going to be my equation. So that's the one time that I do not solve for C first. If I get a natural log on the left side there, I tend to do that e to the step and solve for y first. So let's try another one. You go to the back side there. This one looks kind of similar. Find the general solution, okay, to the differential equation here. So here we go. Let's do our steps. dy dx. Oh, let me just do this. Let's separate. I think you're with me that this y minus 2, he's together. I'll move him to the left. So that would be y minus 2 on bottom. And then I'll pop that dx over to the right. So I would have sine of x dx. What's my next step? Integrate, integrate. So when I integrate, I would have the natural log of the absolute value of y minus 2 is equal to the integral of sine. Who has a derivative of sine? That would be negative cosine of x plus c. I do have an ln on the left, so I'm going to go ahead and do that e to the step. Now that you've seen it, again, you can kind of not write as many steps, but I'm going to write it one more time. I would have e to the negative cosine times e to the c. This becomes your big C. So I have this right here. This is when I can drop the absolute value. So when I pop that 2 over, my general solution is CE to the negative cosine of x plus 2. And this is my general solution because, again, I haven't solved for C. A general solution has C in there. Now part B says, okay, with that differential equation, find the particular solution if f of pi over 2 is equal to 8. So in other words, if I put in pi over 2 for x, I should get out 8 for y. So let's see what I have. I have e to the, well, the cosine of pi over 2 is 0. So e to the 0 is 1. So c plus 2 is equal to 8. So c is not negative, c is 6. So what's my answer? My particular solution is y equals 6e to the negative cosine of x plus 2. Very good, very good. All right, last one. It's a multiple choice. So you got to get there. So you've got to use, your stuff until you get there. So it says if e to the y dy dx is 2x and y of 1 is 2, then the particular solution is what? All right. Stop the video, see what you get. Here we go. Let's separate. I have e to the y dy is equal to 2x dx. I'm going to integrate and integrate. So I have, let's see, the integral of e to the y dy is just e to the y. And then this integral is x squared plus c. Now again, I don't get an ln, so I would solve for the c right there. You can do it in two different spots. I like to do it here when I don't get ln, so I'm going to keep with that. If I put in 1 for x, I should get out 2 for y. So I get a very weird c value, e squared minus 1. Yeah, that's kind of weird, but that's what I get. So remember, I go right back to where I have. So I have e to the y is equal to x squared plus e squared minus 1. Now I'm having to solve for y. So again, how do I undo an e to the? Well, that's when I do the natural log of both sides. And so ln of e to the y is just y, and I'd have natural log of x squared plus e squared minus 1. And as weird as that looks, that is an answer choice, and I got it. So there you go. So it's the same idea of solving differential equations. It's just doing a little bit different solving for C and the timing. All right, good luck everybody.